All right, in this last video for section 1.3, we're going to cover one more example and then talk about a slightly different topic. So the last example is probably one of my favorites. It's a geometric example. These tend to be nice for people because we can visualize and draw a picture. So this one's the length of an American football field is 200 feet more than the width. And we're told the perimeter of the field is 1,040 feet. What are the dimensions? So one thing I am going to note here. There we go. Is on page 133 in your text is a really nice chart that has 10 different shapes. So you have squares, rectangles, circles, triangles, trapezoids for your two-dimensional, and then you have the cube, a rectangular solid, so like a box, a circular cylinder, a sphere, and a cone for your 3D shapes. And it does have your beginning formulas there. So you have your perimeter, your area, and your volume for the relative different shapes. So I do recommend checking out that table. Here we're going to focus on a rectangle. So if you think about a football field, it's rectangular in length, right? It looks kind of like this. But if you go into your book, it will actually give you the formulas for perimeter there, and area, and so on. All right, we're looking for the dimensions. So when we're talking about a football field here, we're in two dimensions, right? You have a length and you have a width. So my goal here is to find the length and width of the field. So I have two unknowns. I have my length. And then I have my width. So one of these is going to be my variable, and the other one is going to be written with the x somehow. So let me read through again. And I see that the length of the football field is 200 feet more than the width. So I'm noticing that my length is being compared to the width. So it's being talked about in terms of the width. So the width here is really what's more important. So what we're going to do, if I rewrite this, how do you write 200 feet more than the width? Well, more than means plus, and I can let the width be x here, or you can use w if you want. So my length is 200 more than the width, which means that the width must just be the x. So as I read through, I see that that width is a bit more important. It's going to get that variable of x, and I can easily write my length in terms of the x if it represents the width. So my picture looks like this. So my width is x and x, right? Because you would actually have the width and the length on all sides. And then my length here is 200 plus x and 200 plus x. Now, the other thing we know that we haven't used yet is we know that the perimeter is 1,040 feet. So what is the perimeter? The perimeter is the outside of an object. So basically you just add up all sides. That's a perimeter, and it works for any sort of shape. Obviously not a circle, but if you have any shapes that have sides, if you just add up all the sides, that's your perimeter. Now in your book, they have more specific formulas. So the perimeter for a rectangle is twice the length plus twice the width. But you can see that you can get that just by adding up all the sides, right? I have a length and a width and a width. So clearly I have two lengths and two widths. So that's all your formulas are. So if you forget the perimeter formula, just add up all the sides. So here, I'll use the one in the book, but I could easily just add them all up. So it's twice the length plus twice the width. My length here is that 200 plus x, and my width is just x. Or again, you can just leave it as w if you want to, instead of using x's. Now I can go ahead and solve. I'm going to go ahead and distribute here. 400 plus 2x plus another 2x. I'm going to combine my x's. I'm going to subtract 400 from both sides. And then I'm going to divide both sides by 4. And I get x is 160. So let's plug this back in. So our width here is 160, and be careful, this was in feet. I want to make sure I note my units. And my length here is 200 plus 160, which is 360 feet. So an American football field is 360 feet by 160 feet. So we have our length and we have our width. Now, how can you check this? Well, there's a few different ways. So first of all, it does seem logical, right? I'm expecting larger numbers here. I don't have any negatives. If I add up all my sides, so if I take 160 plus 360 plus 160 plus 360, I should get that 1040. So that checks out for me. The other thing I could do, if anybody knows football, then you could just actually look up and see if this is correct, right? It is. So the dimensions of an American football field are 160 feet by 360 feet. Usually we talk about in terms of yards. So it'd be 120 yards is the same as 360 feet. So it actually is correct. And just another way that you can verify. One thing I will note, when students tend to do perimeter of rectangles, the biggest mistake is they forget to multiply those two sides by 2, or they forget to add in all 4 sides. They only add in half the sides. So that's one thing to watch out for. It's really common. I always see students, they'll do 200 plus x, and they'll forget that they have another length and another width that has to get incorporated. So keep that in mind as you're going through. All right, so one last thing I want to talk about. We've been using a lot of different formulas, a lot of different equations here, but of course you can also rewrite equations. We can rearrange them. Sorry, that's my puppy. So what we're going to do is we can solve a formula for a variable, which means to rewrite the formula so that the variable we want is isolated or by itself on one side of the equation. So when we do this, we're not actually getting a value. We're not plugging anything in or solving and getting like x equals 4. We're rearranging the formula so that the value or the variable we want to focus on is by itself. So here, so we just use this formula. Perimeter equals twice the length plus twice the width for a rectangle, but perhaps I want to solve it for L. So what I'm doing here is I'm really saying to myself that L is the variable that I want to isolate. And I kind of pretend like everything else is just regular numbers. So L is the one I'm solving for. So you're going to use your regular solving techniques here. If I had parentheses, I would clear up parentheses first. If I had fractions, I could clear out those fractions. I would combine like terms and do all the regular stuff first. And then once all that's done, you want to start to get that L by itself. So just like with regular solving, right? If I had something like 4 equals 2x plus 6, the first thing you would do is bring that 6 to the other side. You would do that adding and subtracting first. And I'm going to do that here. So I'm going to bring that 2w to the other side. Now, the thing that's different is that you're not going to actually combine anything because they're not like terms. It doesn't really matter the order you write it in. A lot of times we like to write the minus part second, but you could either write negative 2w plus p or p minus 2w. So that's just like this step here. And then your next step, you would go ahead and you would divide by that 2 on both sides. So I'm going to do that here. I'm going to divide by 2. So I can write my formula like this. Or if you want to, you could actually separate this out. And if you do that, you're going to put each piece over the 2 like this. So all parts have to get that 2. And then you simplify individually. So p over 2 stays, but I could cancel these ones out and just get minus w. This is also correct. When you're simplifying, if you have individual fractions, they just simplify as normal. you have a large fraction like this, you can only simplify if I can cancel the same factor in all parts. So I know I see a 2 over 2 here, but I cannot cancel it because there's no 2 with the p. I would need a 2, 2, and 2, and then I can cancel. So just be really careful. A lot of times students start canceling things when you have these complex fractions, and you can't do that unless all parts have the same factor. If you want to cancel, then separate them out, and then you can simplify individually. Okay. Now, this next example is actually a challenging one. We have our formula here. It's also based on interest, another kind of finance formula. And we want to solve it for P. So this is a little trick I'm going to show you for this one. Now, notice here that I have P in 2 spots, whereas over here I just had L in 1 spot. And the other problem is that these are not like terms. PRT is not the same thing as just P. I can't combine these together. So the trick here, when you have something like this, is you're actually going to factor out that P. So if I take the P out, I'm going to divide it out. Think about what's left. Well, if I take the P away from here, there's a factor of 1 there. And then here, if I take the P away again, P divided by P is 1, and I also have the R and the T. Now, you do need the first, I'm gonna actually write it this way. You do need the first number 1 because I need something there. You don't need the second number 1 because 1 multiplied by R is still R. So I can really kind of just get rid of that and write it like this. If you're not sure if you factored correctly, multiply it back in mentally and check. P times 1 is P. P times RT is PRT. So I haven't changed the problem. Now what you can do, I want that P to be by itself. So I'm going to divide by this group. I do have to divide by the whole group. It's all stuck together in parentheses. And then I can get my value of P equals A over 1 plus RT. So that's one of those tough ones. That's kind of a little tricky one where if you can't figure out how to do, and it's like, I can't combine those terms. I can't get P by itself. I'm trying to rearrange things around. It's not working. Try factoring it out. And you can see that depending on which variable you're solving for, your strategy is going to change. So for instance, here, let's say I solve this for T. So now I'm focusing on getting T by itself, where here I had a P and a P. Now in this case, again, I don't have any like terms. So you do want to check for like terms first. I don't have any like terms, but I only have 1 T, so this is different. What I can do here is bring this P to the other side first. So A minus P. And then I can divide by PR. And then I can get my variable alone that way. So these are almost like little puzzles. You really want to think about what variable you're trying to get by itself. Go back to your regular techniques. If there are parentheses or fractions, do all that first. And then think about, okay, how can I rearrange to get that variable alone? For most of them, they're not going to be as complicated as this. Most of them, you may have some like terms, you may have some parentheses to clear first, but in general, you're going to have probably just one of that variable left after you've combined like terms. And then once you have that, then usually you're going to do some sort of adding or subtracting first, and then some sort of division. So this tends to be a pretty general procedure a lot of times. But again, look at each one like a little bit of a puzzle and think, what can you do to get that variable by itself?